Hello, everybody. Good morning. My name is Abdul. I'm working for a company called Bester Business. First of all, thank you so much for joining. I am joined with here with my colleague, Mr. Fabian, and one of the colleague of one of our partners, Mr. Jax as well. He will be explaining a little bit about our partnership with the company manufacturer of the data diode. So thank you so much for joining. The topic of today's webinar is how we are going to implement data diode based security in the industry. So for example, during this meeting, if you have any questions, you can write in the chat as well. So the context of this this webinar is divided into the subject at how we are going to implement the data diode based securities using the hardware solution and using the software solution, and how both solutions are compatible. So in this meeting, we are going to explain you about little bit about our company, what is data diode system, and what is how the data diode works, what is the nature of implementing a solution with hardware and with software, and how both solutions are compatible. We're going to explain a little bit about our partnership with a company called Exaion. They are basically a part of the EDF group, and they are the manufacturers of data diode hardware. And we are going to show you a little bit examples of the success stories that we have implemented the solution with the hardware data diode, and some typical architecture. And at the end, you will we will show you the demo of how you can implement the solution using our connectivity platform, which is called vNode. So let me little bit give you introduction about the company. So the name of the company is Bester Business. Inside Bester Business, we have multiple divisions. I belong to the connectivity division. So we have three divisions. Number one is the connectivity division. Then we have SCADA division, in which we have a dedicated SCADA, which is called AtWise, which is pure web-based HTML5 SCADA. And then we have a training division, which is called VITC, in which we provide trainings about multiple topics. For example, cybersecurity, for example, OPC technology, industrial protocols, and many others. Inside the connectivity divisions, we have two offerings. One is from the Metricon OPC solutions, and the other one is our own connectivity platform, which is called vNode. And this webinar is more focused on how we are going to implement vNode with the data diode functionality, which is inside vNode. So I will hand this presentation over to Fabian, and he is going to explain you everything. And in the meantime, if you have any questions, you can always write in chat. Thank you so much. Over to you, Fabian.
All right, thank you so much. All right, can you hear me well?
Yeah.
Good, excellent. Okay, so the first slide is about what is the concept behind the data diode system. So probably, as you recall, years ago, so we had one network, probably we're talking about an industry, any industry, and we have control networks and IT networks, and for a very long time, or also from the IT network to the outside world, we do have different networks, and for many years we just had simple firewalls between these networks in order to protect what was happening or who had access from network to network. So we had these firewalls, and we could create rules in these firewalls in order to allow or not allow different technologies or protocols or ports or applications or IPs or computers to send data through the firewalls from one network to another. So nowadays, in some occasions, simple firewalls are not enough, and that's why we are presenting here the data diode system. So data diode actually is the concept of course, a security mechanism which allows the movement of the data just from one side to another, from one network to another network. You can have many different hardware and software in one network, probably in the secure network, and you want to move this data from a secure network to an insecure network. This insecure network could be another network inside your own plant. This insecure network could be the outside world, could be the cloud, could be an external network, could be another company, could be internet. So the data diode idea or concept is the concept of moving data securely from the secure network to the insecure network just unidirectionally, just in one, from the secure network to the insecure network in only one direction. So there are many different ways to do this. So in order to perform this movement of the data in just one direction, of course, there are different ideas behind it, or things we need to accomplish. For example, we need a one-way data flow. So in these cases, we are trying, or we're looking for to move data from the secure network to the what we call the insecure network in a one-way data flow. The idea in this case is to provide data to these applications living in the insecure network. And of course, in this case, we're not looking for any feedback. We're not looking to write anything back to the systems in control, all right? So this is what I'm saying, that that diode concept is just very specific for, of course, very specific uses in order to move the data to other companies, to move the data outside the plant, to move the data to insecure networks. Of course, we're in situations when we don't need to write back to the control systems. So apart from the one-way data flow, we have a physical or logical separation. So because of this, of course, there are different approaches to a data diode system. We can have a software solution, or we can have a hardware solution, or we can have a mix between a software and a hardware solution. And this is actually what we are presenting today. On the first side, we do have the software called vNode, which we're going to be doing the presentation in the next slide and the demo later. And vNode is a IoT gateway, has many different functionalities to collect the data and to deliver the data. And also, one vNode can be connected to another vNode. So one vNode can be collecting data, push the data to the second vNode, and the second vNode can be delivering the data to the applications on top. So one offering inside vNode is the option of what we call the Data Diode module, which is moving the data from one vNode to the other vNode using UDP transport protocol instead of using TCP/IP. This way, we are collecting the data with vNode number one, pushing the data to the vNode running in any computer in the outside, and then there is no coming back. There is no callbacks, there is no writing back, nothing else. So whatever happens in the outside will never have an impact in the vNode in the inside. And the vNode in the inside will always be keeping collecting data no matter what is happening in the outside. So this solution is, of course, a software solution. So this relies on computers and relies on switches and firewalls and typical firewalls with typical rules allowing only UDP connections through a firewall from a network in the inside where we have one vNode to a network in the outside where we have the other vNode. So a more secure approach is a hardware solution. And here we have Jacques Desmarais from the company Exaion, who is going to show us today their solution, the solution from Exaion, which is a hardware solution. And of course, the idea of a hardware solution is moving the data unidirectionally by using optical fiber. Of course, both solutions can work separately and both solutions can work together, because not only you can move the data from point A to point B using optical fiber by using the appliance from Exaion, but also you can do that using UDP transport protocol, having a vNode in the inside and a vNode in the outside. So both solutions are very compatible, and this is what we are doing today. All right, so Apart from this, we are looking for, of course, security and integrity. So data can be encrypted. And of course, the use of the right hardware and the right software will give you the security and integrity of the data, knowing that everything you're collecting in the control network is going to be sent 100% to the vNode in the outside, and is going to be delivered to the applications on top. So presenting a little bit very quickly about industrial IoT gateway vNode. So vNode is, as I was explaining, is a software which is created on modules. Each module is, let's say, a functionality. And inside vNode, we have today about 50 different modules or 50 different functionalities. Some functionalities to collect data, some functionalities to manage the data, for example, to make calculations or logic inside vNode, so you can collect the data from different technologies, for example, from Siemens PLCs, from power inverters, from OPC DA servers, from databases, from REST servers, from MQTT, from ABB PLCs, from OPC DA, OPC UA, XML DA, and many other technologies. You can collect the data, you can make logic and calculations, you can share the data to this vNode on top, and this vNode on top, which is running in another network, could be delivering the data in real time to all the applications on top, again, using different technologies, using, of course, sending data to databases, sending the data to the cloud, sending the data to any SCADA, or sending the data to SAP or to OSI SOFT PI, any application on top, by using different technologies. For example, REST, OPC UA, Modbus, MQTT, and so on. All right. So I'm going to give to present, Jacques Desmarais, who is going to explain us their approach on their Exaion gateway. Jacques, are you there?
Yes, I am, of course.
There
Hello,
you go.
everyone. My name is Jacques Desmarais. I'm located in France, and I work on security products within Exaion, especially on our Data Diode, mainly on the global architecture and hardware aspects. A few years ago, I've been involved in some vNode implementations, including its deployment in one of our two main data centers in France, and I'm also involved in future vNode deployments in our brand new data center in Canada. This slide shows Exaion. Let me first introduce you very briefly who is Exaion. Exaion is a 100% EDF subsidiary that has been in existence since early 2020. EDF is, as you may know, the historical electricity provider in France. The story started with the idea to reuse supercomputers that were about to be decommissioned in order to give them a second life. From there, a broad range of solutions were built to meet the following challenges: performance, data sovereignty, carbon footprint reduction, dependence on external suppliers reduction, and so on. Today, Exaion is 60 people on 3 locations, 2 continents, 4 data centers, and 2 founders. You see their picture. Fatih and Laurent were both former EDF employees. During this journey, we have developed our own network data diode solutions, Exaion Gateway, for our own needs and as a competitive advantage for the EDF group. We recently decided to open the valves and make it available to external markets, and that's what we'll be talking in the next few minutes. So, as you may know, today, most industrial installations rely on data to improve or even just maintain their production to the best achievable level. But a factory, a plant, is not a data center and does not have in general the computing resources needed to bring the expected value out of the gathered data. We are talking here about a large number of very granular technical data or tags like pressure or temperature, for instance. For this reason, production data needs to be exported outside of the factory premises to a data center, where big data solutions and AI will make it possible to change this data in real value for the factory. As you attended today's webinar about Data Diode, you should now be convinced that firewalls are not enough, because like all tools, they have strengths and weaknesses. And especially as software-based solution, they remain vulnerable to backdoors or more commonly configurations error. The good news is that there's a solution, Data Diodes. To make it simple, Exaion Gateway is a data diode entirely designed and made by Exaion, a cybersecurity solution allowing data to be transferred from a sensitive site to another site while granting protection against all risk of intrusion. At Exaion, we produce two different versions of the Exaion Gateway, named K0, the one you see there, and K1. With the K1 model, the blue one, as you'll see later, you have a complete autonomous data diode in a typical 2U format. It is meant to be positioned between two networks. Embedded, you'll find two servers, specific unidirectional optical fiber module, and a few custom boards used to expose the desired RJ44 at the front panel. And that's really what makes it different from the K0 model. Inside, you'll find as well a software taking care of all the data transfers and making them compatible with UDP, unidirectional communication, as Fabian said before. The K0, if you can come back on previous slide, please, Fabian. Yeah, this one, the black one, is the simplest appliance and is meant to be connected to two external servers. It only contains the unidirectional optical core and is 100% passive. To say it in a different manner, it does not require any power supply, which makes it especially suitable for some markets in emerging countries where the electricity network could be, let's say, improved. As it's probably the model that will catch your attention the most for use cases with vNode, let's see it more in details in next slide. So with the K0 model, we adopted a modular approach with pluggable cassettes that can be inserted into the 1U case of the K0. You can see these cassettes at the bottom of the screen. Each cassette contains two passive data diodes with LC connectors, and up to 3 cassettes can take place in a K0 for a total of maximum 6 passive data diodes in a 1U format. The K0 is meant to be connected to two external servers and can transmit any unidirectional UDP data flow with no control, like syslog, CNMP traps, and of course, the flow sent out by a vNode data diode module, for instance. The detail of its internal functioning are, of course, confidential, but to keep it simple, keep in mind that we use light whose polarization we alter in such a way that it can flow in one direction, cross some optical devices while preventing any way back. Light can therefore only circulate in one direction, so can data. The Exaion Gateway K0 is typically the model that can take place between two vNode servers, securely allowing a source vNode server to be replicated on a replica server on an exposed side, like Fabian said, with the help of a specific module inside vNode, which is called the Data Diode module. As the Exaion Gateway K0 doesn't contain any software, it's purely hardware, there's no extra configuration needed, but of course the configuration in vNode. Let's now see on next slide the typical implementation. No, sorry, I was already at that slide. I mixed myself, sorry. So now the next please, Fabian. This one, okay. Let's here take as an example a use case where you have to provide your customer or anyone with a replica vNode server in an exposed network zone. The replica server will replicate what's available on the source vNode production server, well protected on the industrial sensible site, the plant. Obviously, as security is not an option, the data from the production server to the replica will flow through a data diode. Here, our Exaion gateway. The data diode will guarantee that, it's really a guarantee. The data diode will guarantee that nothing or no one from the exposed network could ever access the protected network where all the sensible infrastructure is located. On this picture, you can see two vNode servers connected to an Exaion gateway. Here it's a K1 model, but it just could be as well a K0 instead. To make it simple, with the K0, you need to have these two external servers running vNode, whereas with the K1, you can have two external servers as on its pictures, or you can as well imagine to install vNode directly on the two embedded servers of the K1. Most of the time, if we are talking of a big number of tags to be gathered, the best solution will be to go for a passive K0 and two external servers on which you will install vNode and the Data Diode module. On the small pictures at the bottom of the screen, you can also notice that we have provided the possibility of installing the K0 cassettes on a DIN rail instead of in its 1U case, thanks to the small green plastic part present at the back of any cassette. Typically, it helps to install the K0 in an industrial electrical panel, for example, where no additional IT rack exists. Regarding connectivity, on this picture of the K1 model, the blue one, you can see that it exposes two main RJ44 network ports marked AMT RVL. The empty side is the protected side, whereas the AVL is for the exposed side. All the other ports are for administration or specific use. On the bottom left corner, you can see that connectivity is fiber-based on the K0 model. It's some close picture of the K0 there. The LT fiber connectors for inputs are on the left under the keyword in, logically, and those for the output on the right under the keyword out. These connections use classic duplex optical fiber patch cables. One final word, while the K1 model is limited to 1 gigabit per second, with the K0 model, the network speed achievable for the data transfers only depend on the optical network cards of the connected servers, which means that it can go beyond 1 gigabyte per second, for instance. If we could move on to next slide, please. I will now briefly introduce you one of the greatest key differentiator of our Exaion gateway offer in the Exaion in the data diode market, because there's no doubt that it will solve a problem you already have on secure side. All data diodes have the same weak point. Maintenance operations on the sender side can only be done on site because it's protected, hardware protected by the data diode. That means a trip to the site, therefore additional cost, additional delays, and so on. The Exaion gateway that I just introduced you in the previous slide innovates by providing as an option what we call internally a lockbox that we developed specifically and that will make it possible for technical experts to remotely connect on the upstream side, I mean the protected side. This can be seen as a kind of maintenance mode that can be manually activated, like a light switch at home, for a predefined period of time. And I mean there by a real person on site and protected with a secret code. There's no computerized thing there. You will typically be able to use it to remotely configure production servers on remote sensible sites, despite the fact that they are well protected behind a data diode. At the end of the operation, the maintenance operation, for instance, this can be immediately canceled. And in any case, it will be at the end of the predefined period, meaning that there's no risk to forget. Being a strictly manual action on a totally independent piece of hardware of the data diode, it cannot be hacked, and therefore it does not weaken the level of security of the Exaion gateway. The vNode production servers and the plant stay protected at all times. Now we can move on to next slide, please, Flavian.
There you go.
So we'll be talking about a few use cases. We have extensively experimented our Exaion gateways or data diodes with vNode for years now. So far, we made 2 successful implementations in France and 1 to come in Canada. Starting from the left is a use case involving a K1 and custom scripting to securely export data from the production vNode server and offer at the same time a replica server. This is what we implemented a few years ago before the official vNode data module that makes things a lot easier was written. This solution is currently in production in the major EDF data center in France. In the middle, we are in the typical use case involving a K0 model 2 external servers, and the vNode Data Diode modules. We have implemented this solution in a thermal power plant in eastern France. Industrial tags, industrial data, is collected by a vNode server transmitted through the K0 to remote centralized monitoring system. And finally, on the right-hand side, it's an implementation to come soon in our latest innovative data center in Canada that we just inaugurated 1 month ago. vNode server will be installed as the central OT monitoring solution, gathering data from electrical meters, immersion cooling pumps, air conditioning pieces of equipment, and so on. A second replica, a vNode server, will be installed outside to provide remote access to technicians. The replica will be fed through the vNode Data Diode module and an Exaion gateway K0 with a regular data flow from the protected server. Here we are. Just wanted to make it short. I will now let Fabian go on. Talk to you later at the end of the webinar for the Q&A session. Fabian, it's up to you.
Excellent. Thank you, Jack, very much. All right. So this is the typical architecture where we are implementing a data diode system. So in the left side, we have just the software solution, as I was explaining before, inside vNode. So in here, we have one vNode below. I'm talking about the left architecture. So we have vNode collecting the data from different protocols, Siemens PLCs, OPC UA, Modbus, different options, collecting the data. We're talking about real-time data, or collecting the data from databases, or collecting the data from REST or MQTT. And in this vNode, we have a data diode module. As I was explaining, inside vNode, we have different modules. Each module is doing a different functionality. So in this vNode, we want to use, apart from the modules to collect the data, we want to use this a module called the data diode in order to transmit the data to another vNode in another network. So this data is sent using UDP, encrypted, through a firewall to another vNode, which is also, it also has a data diode as a receiver. So this vNode is receiving all these UDP packages, is converting all this information into tags, again, the same tag with the same values and the same timestamps and the same quality in the same order, exactly the same as it was before. That's why we call this the replica. And then this vNode in the outside is able to send the data to any application in the outside, or the cloud, or OPC UA clients, or MQTT, or REST clients, or databases on top. In the right side, we have the same implementation, but in this case, by combining the software and the hardware solution. So we have the same vNode in using the same data diode module and pushing the data to another vNode in the outside. But in this case, the network goes through the Exaion data diode system. So we'll go through this, the optical fiber unidirectionally, and then through our typical firewall, and then going to the outside. So again, this vNode is going to collect all these UDP messages coming from the vNode in the inside, and then again, can be delivered to any application on top, okay? What is the main difference here? That, of course, in the left side, we're talking about giving a protection by using firewalls. Though, of course, there are different firewalls, more or less expensive, but nothing will be like data diode system, right? But of course, we're talking here about a situation where we do not need to write anything back, because in the moment, since we install a data diode firewall, so we cannot write back anything. That's the idea here in this case. So yeah, just to show two different approaches about different data diode solutions. In the left side, only software data diode by implementing the vNode modules using a typical normal firewall. And in the right side, by combining that diode module in vNode and also using the Exaion data diode hardware. All right, so I'm going to show you a quick demo how to use this data diode sender and receiver in vNode, and then I'm going to go through a pfSense firewall. Probably, well, this is a software firewall. Probably you know very well. It's actually an open source firewall, which is running in a virtual machine here in my office. So here in this case, I have one vNode, which is collecting the data from, I think, Modbus and OPC DA. Of course, can be reading from multiple technologies at the same time. But in this case, just to make it easy and to make it simple, I have this IP 192.168.3.32, and I have a virtual machine running in this, running a vNode in this computer. Okay, so I have vNode reading data. I have only 3 tags from one from Modbus and another 3 tags reading from OPC DA, a simulation server from Matricon. And then by using the data diode sender, I'm pushing the data through the pfSense firewall to another vNode, which is running in a completely different network. In the IP 10.10.10.5, these 2 computers are completely disconnected, and the only way of making a connection here is by allowing one rule that I already have created in the firewall, which is only allowing the data movement from this internal computer to the external computer, and only using UDP. So no matter what happens, nothing can come back from this computer to this computer. On one side, the firewall is in place. It has a rule to move the data only from this computer to this computer, and also because this is UDP, so this vNode is not expecting anything back. So no matter what is coming back, this vNode in the inside, in the protected zone, is not going to be expecting or processing any feedback because it's not expecting any message back. So then on top, I'm going to be using a testing client called the UA Expert. Probably you know it. It's a very simple OPC UA client, in order just to test and to see the data we are moving, Modbus and OPC data, we're moving from one network to another. So allow me to show you, this is the first computer. So this is the computer inside the protected zone, okay? So I have this vNode here. vNode is a software that is, the configuration is a web server. So what we configure vNode just by using here a web browser. I'm using Chrome in this case. So in this computer, let me show you. I have here, just to show that we don't have connection to the other computer in 10.10.10.5, no ping, nothing. So in this computer, I have the Matricon OPC simulation server, and I have this Modbus simulation as well. This is a Modbus slave simulator. So I will write some values here. So this is we're going to be reading holding registers. This is the 40,001, this is the 40,002, and this is the 40,003. These are 3 tags we're going to be reading in a second, and these 3 tags are changing very, very fast. So in vNode, let me show you, I have created here one module, which is a Modbus client, one module, which is an OPC DA client, okay, and another module, which is an OPC UA server. For the moment, I didn't create the data diode module. So just to show you a little bit. Yes, please.
Unfortunately, we cannot see the screen where you are performing this demo.
Oh, really? Sorry for that. Let me, because maybe I was only sharing the PowerPoint. Let me go back again and share my screen instead of the presentation. What about now? Here?
Now we can. Now we can.
Yeah. All right. All right. So You were not. So I was showing the CMD, showing the pin is not going through, showing this Modbus simulator, which we're going to bring these 3 tags, which are changing every second and a half, more or less. Okay, and I was actually showing vNode, which is running. Actually, we're showing the configuration of vNode, which is running in Chrome, because vNode has a web server in order to make configurations. So I have a module is called the Modbus client, a DA client, and an OPC UA server. Okay, these are the 3 modules I have created inside vNode in this computer, which is the 192.168.3.32. This is the vNode in the protected network. So if I very fast, I go to the OPC DA module, we can see that I have a channel called C1, which is reading from the Matricon OPC simulation. And I have a module called the Modbus master, which is reading from localhost, the port 502, and the device is the slave number 1, which is our device, this one. Okay, so we have these 2 modules. One is the Modbus client, the other is the OPC DA client. If I go to see my tags, I created a very simple architecture, a very simple organization of tags, which is a folder called Modbus with 3 tags inside. These 3 tags, they are linked to this Modbus client module. It's called Modbus client, Modbus master, actually. Here, I'm reading from the channel 1 device 1, which is this one, channel 1 device 1, C1D1. And through this module and through this channel and device, I am reading this memory position, and this memory position is an integer 16 bits. Of course, if it was something different, I can change it. I'm going to be reading, let's say, every I don't know, let's say every second. There we go. So I have another memory position, all the same, except the memory position is different. I'm going to be reading the 4002, and then the same with the 4003. There we go, and I'm saving this. So if I go to real time, I go to Modbus, we can see our 3 tags in here, right? We can see our 3 tags. If I change something in my slave, we can see that we are reading that change. Then what else? We have the OPC DA tags. So I have my int1 tag, which I created, is linked to my OPC DA client. OPC DA is the name of this module. And inside this module, if you remember, I have a channel 1, which is reading from the simulation 1. So I have my channel 1, and I'm reading this tag. It's called random.int1 every second. So I am reading in int1. Int2 is exactly the same, but here I'm reading int2, and int4 I'm reading exactly the same, but int4. So if again I go to real time, I go to the OPC folder, I'm reading these 3 tags. If I go here, I press sublevels, I can see my 6 tags. All right. So we're still in the protected network. So let's say in the protected network, we do have a local SCADA, local application, in order to monitorize this zone or this network or this plant. So for that, I have an OPC UA server running inside this vNode, exposing this all these 6 tags. So right now I enable security. Is listening this port in localhost. So if I just open my OPC, the UA expert, we can see that we are connected here to the vNode OPC UA server, and we are reading here all our tags, right? Modbus and OPC, and we are reading all these tags again, because we are in the protected zone from the OPC UA client. Here, if I let's make it a little shorter, like this. So if I go in here and I make a change, of course, the change will go to the here. If I make a change in this number will go to my device, right? If I make a change, this is read and write. So I can read, I can write. There we go. Maybe I made this read only. Let's see on this one. I made only one read and write, which is the 40,001. This one. There we go. Yeah, I only made read and write the first one, which is this one. This is read and write. This is read only. Let's make it read and write, all of them, the three of them. Read and write. There we go. Okay, so now from here I can. Now I can read and write. Okay, so now that we see that we are reading the data and locally we can read and write into our simulator, which is this Modbus slave. Let's create our module in order to send the data to the outside. So in order to do that, I go to config modules. I'm going to create a new module. It's going to be called Data Diode. There we go. So in this drop-down, I have all the modules in vNode. Starting, we have to speak with ABB PLCs or BACnet, or here is my Data Diode. We can make calculations with derived tags. We can export CSV with the data exporter, CSV files, read from DNP3 devices, or read from IC 104 devices, or Modbus, or Metal Toledo devices, MQTT, OPC DA, OPC UA, REST. Well, there are many different Siemens is here. We can run scripts. We can read from REST, and so on and so on. We can write data into databases with the SQL client. Well, in this case, I'm going to, of course, select the Data Diode module. All right, so I'm going to save this, and now I have here to configure my Data Diode module. So in here, I'm going to create a sender because I'm in the protected zone. So I'm going to create a sender. I'm going to call this S1. Okay, so what is going to be our destination? Our destination is going to be 10, 10, 10, 5. There we go. And the port, we're going to leave the 4001. Of course, we can change if we want. But the rule I have in my firewall is already using this port. So enable encryption. I'm going to put a secret, just 1, 2, 3, 4, something really simple right now. And then we have other fields for that integrity. We can repeat the messages several times. There is a check interval and so on, a send rate, well, some other things to change. Let's check the send rate to 1 second. And then we need the tag filters, which is the list of what tags I want to send to the other side. Because maybe I have here 50,000 tags and I only want to send to the other side, maybe only 100 tags. So I can make filters and I can only select whatever I want. Only Modbus, the Modbus folder, only the OPC folder with all these tags, only one tag, or in this case, I'm going to select everything. So the slash means everything, and I press the save button, and that's it. I have this already sending the data through to my firewall, trying to arrive to the other side. All right, so I'm going to open the other vNode on the other side, is this one. This is the vNode on the other side, 10.10.10.5. If I go here, we can see that I only have the web user interface. I don't have any module in this side. So I'm going to create a module here, which is going to be Data Diode. All right. Again, I'm going to select Data Diode. All right. And here I'm going to I have to configure this data diode. All right, so in here, I'm going to create a receiver. I'm going to call this the R1. All right, so we are going to allow data from anywhere with my secret 1, 2, 3, 4, and I can allow the connection from anywhere. Okay, so so I'm going to allow the incoming connections. No, I'm going to allow the incoming connection from any IP. All right, so I can allow connection just from specific IPs if I want. I'm going to allow and leave it like this. All right, and save, and that's it. So now in this side, I have to create my tags. So I'm going to create exactly the same tags. So I'm going to create a new group called OPC, and inside OPC, I'm going to create int1, and int1 is going to be, of course, read-only, and the source is going to be the source of the values of this tag is going to be the data diode here. The module is going to be data diode, and the receiver is going to be the R1, and that's it. Then I'm going to duplicate this one. I'm going to create, well, not of course, I'm going to create the same structure I have on the other side. This, of course, is not mandatory. I can create any name of tags as I want, but in this case, it's easier if I just create exactly the same folders and the same tags inside. Okay, this is going to be tag 1. Okay, and here I'm going to duplicate and create the tag 2 and the tag 3. Duplicate tag 3. All right, so I do have my tags exactly the same in both sides. Okay, so right now, if I go here, I have no data. Why is that? Let me show you. If I go now to see my pfSense, so this is the configuration of my, let me show from this side, configuration for my firewall, okay? My firewall has actually disabled all the rules from WAN and LAN, and the rule I want to activate is this one. Is the rule to allow the movement of the data from this IP 192.168.3.32, this one, to the other side. All right. So I'm going to let's see if I can. Yeah, let's do this, and then I'm going to select this. I'm going to put it in this side here, and I'm going to select this one, and I'm going to put it on in here, so we can see all of them at the same time. There you go. All right. So let me go here, modules, because I do have a demo license. So all modules they run for 2 hours and then they stop, unless, of course, you have a real license. And then, of course, they run all the time. In this case, I'm running demo licenses, so my modules are running for 2 hours. So this gives you the option about download a vNode, install vNode, run vNode without a real license. So I'm going to enable this rule, apply changes, and if I go right here, we can see that we do have some tags here. This is the outside computer. I created wrongly the name of the tags. The names are 40,001, 2, and 3, and I call them tag 1, 2, and 3. So I'm going to make a quick change in here. So I'm going to, there we go, config the name of my tags right here. I'm going to change this to rename. It's going to be like this. Like this, and like this. Rename. There you go. And save. If I do have the same exact same names, I don't need to specify what is the tag in the inside and what is the tag in the outside. If I have different names, of course, I need to explain to vNode, hey, this tag in the inside means this tag in the outside. There we go. All right, so we have 192.168.3.32, which is the protected computer in the inside, and this is the computer in the outside. As we see, we have exactly the same values, okay, and the same tags, and we have a flow. We can see that if I go here and I disable the rule, apply changes, but because the connection is already established, I need to come here and I need to delete the established connection. If I go like this, I lose connection in the outside. Stays like this for a moment, and like this. I don't have, right now, I don't have a rule that is allowing connection from the inside to the outside using UDP. If I go here to my rule again, I can enable, apply changes, and I have data again, changing all the time. All right, now I'm going to show you. Now we're in the outside computer 10.10.10.5, and here I do have, let's see, I want to create here an OPC UA server, a UA server, so we can see the data with an OPC UA client, a testing one. If I go here to OPC UA server, and let me move this, all right, and I press save. Here I have my OPC UA server. I need to save the first time all these features. There we go. All right. Okay, so as you can see here, I'm going to allow anonymous users, and I'm going to allow a connection with, let's say, no security. So we don't need to configure that. There we go. So this OPC UA server in this vNode is exposing our 6 tags, these 6 tags, to any OPC UA client in this computer. So in this computer, if I open I also have a UA expert. If I make a connection, I already have a connection here. All right, and all right, I'm going to connect with, let's say, well, we can connect with security. Yeah, we can connect with security. All right. Okay, connect. We need to accept the certificate. Okay, trust certificate. vNode certificate is all right. Okay. There we go. And now I need to go to vNode, and also I need to accept the certificate. So I have the certificate from the UA expert. Come here, trust. And now if we go to the UA expert and connect, we have our address space and we have our 6 tags. But in the outside, we are in the unprotected zone, and we have exactly the same values we had in the inside, but of course, in the unprotected zone. Of course, if I try to write something here, nothing is happening because we don't have access to the inside of the plant or to the protected zone. So no matter if I write anything here, nothing is going to happen. Values are going to not be written in the device. All right, so this is what I want to show you today. Let me come back to my PowerPoint. All right, so you can download vNode completely for free from our website. As I showed, all the modules, all of them, they run for 2 hours without any with the demo license. So just by installing vNode and configuring vNode, you get automatically a demo license, and the demo license for all the modules they run for 2 hours. Means that you can install vNode, you can test vNode, and you don't need to buy a real license until you really need to implement this in a real project. And of course, in that moment, you really need a production license, which of course will run all the modules permanently. Right? You will see that you can download Windows version and also Linux, and also for Raspberry Pi version. Right? So, Abdul.
Perfect. Perfect. Thank you. Thank you, Fabian. Thank you
Back to
so
you.
much. Yeah, thank you so much, Fabian. We have some interesting questions. I will come back to you. Thank you so much, everybody, for joining. So let's have a quick question session. So Fabian, number one question is that what is like the licensing model for vNode?
All right. So in vNode, as we explained, we have modules. It's a modular software. And each module uses an individual license. Why is this? Because in one project, you're going to be reading from Modbus and serving the data to OPC UA. So in this case, you need 2 licenses, one for the Modbus client, one for the OPC UA server. Only 2 modules. You don't need to buy any extra licenses that you're not going to be using in this project. Let's imagine in the future you need to read also from MQTT. So in that moment, you need a 1 extra license for the MQTT modules. You can keep adding modules as you need in your existing vNodes, or you can install vNode with, in the moment you install vNode, all the modules are there. What you do is to license the different modules in the moment you need them, right? Apart from this, all the modules have no limits. So in the moment you have an OPC UA client, let's say, you have no limits of connections, no limits of tags, no limits of users. And the same is happening with all the other modules. All the modules have no limits of tags, no limits of connections, no limits of users, no limits of anything. The limits only depend on the computer where you install vNode. You install vNode in a very, let's say, in a very simple computer, such as a Raspberry Pi. Of course, the limitations come with the CPU of the Raspberry. Means that you still don't have limitations on the connections, but the number of tags you can read are limited because the CPU, of course, is limited. You install vNode in a very powerful computer, you can read 50,000, 80,000, 100,000 tags, no problem.
Perfect. Thanks. And other question is that for one implementation, it's look like it's very simple vNode. But for example, if there are multiple installations and multiple instances, so do we have to like make the configuration for every site, or is there a way we can do it? Like for templates
actually,
or something?
Very good question. So configuration can be created using templates. Means that if you have repeated connections, repeated tags, repeated folders, repeated devices, you can create a template, and then you can create instances of that template, which makes the configuration extremely easy. Because you just need to say, okay, all these connections to this PLC, I have 100 like this, but this is the IP number 1, number 2, number 3, number 4. Just explain the different IPs. You can have the same tags 100 times, or repeated tags, or connections, or PLCs, or data diode connections, or whatever is inside vNode. You can create templates for that and then create instances. Apart from that, everything can be exported to CSV and then imported from CSV later. So if you have your tags in Excel, you can create just one tag in vNode in order to know what are the columns you need, export this one tag to Excel, fill everything in Excel, and then import it later. So it's very, very easy to make large installations. Also, apart from this, you can make a backup of an entire vNode. So then you can move this backup from vNode to vNode and load the backup from one vNode in another one. So if you are going to have the same configuration, the easiest way is to do that. Configure one, create a backup, and then load the backup in the other vNodes, and then you have the vNode already configured.
Perfect, perfect. Thanks. The next question is for you, Jax. Can you please explain? There is a question that the amount of tags per second which we can transmit from one side to another using data diode hardware.
Oh yes, of course. Well, a K0 model, you remember the black one, does not bring any limitation on its own. This limitation will be due to the SFP plus speed, I mean the optical fiber card of the servers, potentially fiber network cards themselves, the ones that are used in the server, the amount of memory and CPU power of the servers, and the limitation of the vNode product itself. But as Fabian said, there's no built-in limitation there. So with the K0 model, no limitation brought by the product. With the K1 model, it's more difficult to answer as we have not let realize such tests up to now. What I can say is that we have an implementation running flawlessly through a K1, running our smart software with a total of about 22,000 tags and periodic updates of about every 30 seconds. All indicators tend to say that we could go higher, as this K1 data diode is also used in parallel for other purposes like log transfers, video flow transmission, etc. Although just having vNode plus data diode module running without our smart software may enable higher figures, but it has not been tested. I would say few tens thousands of tags.
Perfect, perfect. And just last question very quickly, because we have already passed 1 hour. So what is the delivery time for data diode hardware? For example, if we what is the lead time for the hardware to be implemented on site?
Okay, so let's say it depends on the region where you could order for this. Let's say for these devices. In France, obviously, it will be maybe 2 days. In Europe, let's add 1 or 2 additional days. For the region that we consider today Asia Pacific plan, it has to be decided really on a case-by-case basis. It's not really easy at that time. I can't answer that accurately.
Perfect, perfect. Thank you. And last question.
Let me add, Abdul, one good question here in the chat.
Yeah.
We have many. We have to choose. No, sorry. Where we have to. The question is why we have to install firewall if vNode can also serve as a firewall. So in this case, vNode is not serving as a firewall. vNode is pushing data using, in this case, UDP from one vNode installation to another vNode installation. So completely agree that we could have these 2 vNodes running the same network. But if we have one vNode, and I mean the real or realistic implementation is one vNode in one network and one vNode in another network. And in a real implementation, you are going to have a firewall between 2 networks. That's the idea about actually, if you have 2 networks, you want to have them as isolated as possible. And this is why we're using a firewall, right? In order to isolate these 2 networks, and then moving the data from one vNode to another vNode. But vNode is not a firewall. vNode is just pushing the data using UDP from vNode to vNode. So also in the in this case, one vNode is running in a local network in 192.168.3. something, and there could be other computers running in the same network. And also, of course, we want to isolate all those computers from the other computer that we have in the other network in the IP 10.10.10.5, which is in the unprotected network on top. So as we don't want these 2 computers to have access each other, that's actually in this case why we are using a firewall, right? This is the reason.
Perfect. Just last question: what additional cybersecurity features vNode can offer? Like apart from like this data diode functionality, is there any other functionality which we can also
Oh yeah,
implement?
but this is
Keeping in
a
mind.
long topic.
Yeah, just keep it short, and then we can
To give it short, yeah. So with vNode, we can move, well, apart from from the data diode, which is the strongest feature for cybersecurity. We can, of course, decide what tags to move from one side to another. Using OPC UA, we can decide per user and per connection what tags to give to different users, use different passwords. Everything is protected using digital certificates. So everything is encrypted. Everything is using SSL inside vNode and in the connection between vNode and other softwares. What else? So we do support encryption on always. The configuration can be done using HTTPS. Well, actually, it's a long topic, but this is mainly some of the ways.
Perfect. Perfect. Thank you so much, guys, for joining. We will share all the presentation with you guys. You guys can see our contact. You can write to us. All the presentation is recorded. If you still have some questions, you can see our emails on your screens. You can send us our emails as well. And plus, we will share all the details about this presentation. We will share the installer of vNode with you over the email. Thank you so much for joining. Thank you, Fabian. Thank you, Jack.
Thank you.
Thank you, everyone.
Thank you, guys.
Thank you very much.
Thank you.
Take care.
Bye-bye.
Good day. Bye-bye.